Good evening. Here we are for the 9th Arianespace launch of the year. And this is a particularly important one, as we are going to be launching an Earth observation satellite, the second in the Pleiades series, Pleiades 1b. We have had 8 launches since the beginning of the year from French Guiana. We started off with a Vega launch, which was followed by 5 Ariane 5 launches, another Soyuz launch, then another Ariane 5. And tonight, we are here for another Soyuz in its STA version to launch the second Pleiades satellite for Earth observation and for CNES. As you recall, we launched the first Pleiades satellites less than a year ago on December 16th of 2011. Arianespace has a long tradition of cooperation with the Earth observation community. It began here in Guyana on the 22nd of February 1986, when we launched the first in the Spot series, Spot 1, which was followed by 5 more Spot satellites. There were also 4 Helios and 2 ERS launches, 1 large Envisat, and finally Pleiades. As you can see, we've had a very busy year with this mission in the service of telecommunications, science and Earth observation. And with tonight's latest launch for CNES, we can say that we have come full circle. Arianespace, the CNES and Pleiades. So now, sit back and enjoy tonight's launch into the Guyanese sky.
Hello and welcome. I'm Katie Haswell, live at the Guiana Space Center for the 4th launch of Soyuz from its new home, here on the edge of the Amazon rainforest. Well, liftoff was originally scheduled for this time yesterday, but an anomaly was detected shortly beforehand, and the decision was taken to stop the countdown and postpone the launch for 24 hours. So here we are, a day later, everything's back on track. We have reset the clocks and we're ready to lift off in about 12 minutes. Arianespace only authorises a launch if all the parameters are perfect. And these status panels on the left-hand side of the screen here are indicating exactly that. They're showing the health of all the various systems operating across the range. And right now, they're all green. So we are go for launch. We're orbiting the Earth observation satellite Pleiades 1b for the French space agency CNES. It's going to join Pleiades 1a, and together they'll perform a double act, taking high-resolution photos from space. Soyuz is made of 4 sections. We call them stages. The boosters are the first stage. Second stage, the central core stage, or Block A as it's known, and the third stage is known as the Block I. All of those first 3 stages burn liquid oxygen and kerosene. Then we have the frigate upper stage, the 4th stage, which burns storable propellants, hydrazine and nitrogen tetroxide. And then at the very top, at the nose of the vehicle, is the fairing, and it's the ST fairing. The satellite is in there right now, waiting for liftoff, getting ready to join its twin in space to provide one of the most powerful Earth observation systems in the world. A couple of people to mention. This is the mission director tonight, Philippe Roland. He's in charge of all the operations from the arrival of the satellite in Kourou to the up through to the launch, and our range operations manager is Thierry Vallée. He's in charge of coordinating the launch base systems throughout the final countdown, and he calls out the milestones throughout the flight, so you'll be hearing his voice. And there he is now. The satellite was assembled by Astrium at their plant in Toulouse in France, and he's announcing the 1020 mark. And Thales Alenia Space supplied the image telemetry system and the high-resolution imaging instruments, which is one of their specialities. And right now, it's waiting patiently inside the fairing. Now, that's what it looks like in there. We can see frigate, the upper stage on the bottom, The lighter gold structure and the darker gold structure above it is our satellite, Pleiades 1b, for the CNES. High-resolution imaging for Earth observation is its mission, and it weighs in at 970 kilos. Conditions are very carefully controlled inside the fairing, so it's quite nice and cool in there. Pleiades is sitting in first class with its seatbelt on, ready for liftoff. And that white smoke you can see is the liquid oxygen burning off. We're looking at Arianespace top management, flight directorate headed by Jean-Yves Le Gall. These folk make up the highest technical authority for launch operations. They have the final say in the case of any unplanned situations, and the teams working across the base report directly to them in real time. And we have joint Russian and European teams working side by side, because Soyuz is, of course, a Russian-built launch vehicle. It has a prestigious history. It's been the workhorse of the Soviet and Russian space program for 65 years. It launched the first ever satellite Sputnik back in 1957. The various parts of Soyuz are built in Russia and shipped here to French Guiana for assembly. Activities for Soyuz started in the Launch Vehicle Integration Building, or MIC. The first 3 stages were assembled horizontally, starting with the 4 boosters, which were strapped to the second stage, followed by the integration of the third stage. Meanwhile, Pleiades 1b arrived in French Guiana by plane at Cayenne's Félix Éboué Airport. It was then transported to the payload processing facility at the Guiana Space Center. Teams performed a series of tests to check the good health of the satellite in the utmost cleanliness of these dedicated buildings, before filling the tanks, then transferring it to be mated with the launcher. The frigate upper stage was installed onto its stand for autonomous pneumatic and electrical tests, before the satellite was then integrated with frigate. The whole thing was encapsulated inside the fairing to form the upper composite. 4 days before the launch, the first 3 stages of the vehicle were transferred horizontally to the pad. Soyuz was then raised to a vertical position inside the mobile gantry once it had arrived. The upper composite was then hoisted on top and integrated that very same day. All these operations took place thanks to the excellent cooperation between Russian and European teams. And it's that teamwork which has brought us to this point with Soyuz ready on the pad. And as I said, that white smoke you can see is the liquid oxygen evaporating because it's so cold. This is the Pleiades team, everybody concentrating hard. Well, that's the chef de mission there. So what's been happening in the last few hours? Well, 4 hours before launch, the State Commission gave the green light to start filling the tanks. Fueling was completed about 1 hour and 40 minutes ago, roughly. And then just under an hour ago, the mobile gantry was retracted. We're coming up to the beginning of the synchronized sequence. That's when the computers start running all the final checks before the launch, and they certainly manage an impressive list of operations. For Soyuz, it's called Clutch na Start, or Key on Start. Pleiades is an important mission for Arianespace.
Here we are again, less than a year after the successful launch of the Pleiades 1A satellite on a Soyuz launcher from the Guiana Space Center for another major challenge. The launch of its twin satellite, the Pleiades 1B, enabling the 2 satellites to jointly operate as a constellation in orbit. Arianespace has been working for almost 7 years with the CNES to prepare this mission. It has been a long and painstaking process involving hard work from everyone, the CNES in Toulouse and in Kourou, Arianespace, and of course the Russian teams. Thanks to excellent teamwork and thorough preparation, the launch campaign has run particularly smoothly without any mishaps, and thus we are ready on time for this evening's launch. On behalf of the Arianespace and Russian teams, we would like to thank the CNES for the confidence that they have shown in entrusting us with the launch of the Pleiades constellation. Last year, just a few hours after the in-orbit separation of Pleiades 1A, we received the first images taken at an altitude of 700 kilometers, and we were very impressed by their quality. We wish Pleiades 1B the same success.
He's right. The images really are stunning. I have to be honest, I keep stopping in front of a picture of Bora Bora and staring at the beach huts, if only. Anyway, back to reality, and we are 4.5 minutes to launch. Frigate is now switched to onboard power. Here at the spaceport, we have a lot of facilities spanning a vast area, and the whole thing is known as the range. Mission Control's just one of the buildings. Others include the assembly buildings, for example, the satellite buildings, the tracking stations dotted across the globe, and of course the 3 launch zones. This is the brand new Soyuz launch zone that we're looking at right now, and this includes the pad, and it also includes the Launch Control Center. And whereas mission controllers deal with the whole mission, launch controllers deal solely with the launcher. And here they are. We have 2 teams working in launch control, and on each side there are 2 more teams because we have two-way cooperation between the Russians and the Europeans for Soyuz. One team is led by the launch site operations manager. They're responsible for the ground operations. And there's Alexander Chervan on the Russian side. And the other team is led by the Arianespace production manager. Tonight it's Marc Roy, and they're responsible for the flight readiness of the vehicle. And on the Russian side tonight, it's Dmitry Baranov. In Baikonur, launch control is in several bunkers underneath the ground, about 50 meters from the pad, whereas here in the Guiana Space Center, it's actually in a protected building about 1 kilometer from the pad, which is where they're all sitting now. Now take a look at that big grey metal mask. That's the upper composite umbilical mast, or the KZM, and inside it are all the umbilical lines which are connecting the satellite to the teams on the ground, and they're sending information from the spacecraft to those teams on things like power voltage and temperature. And we just heard there that those lines are being disconnected now. The upper composite drop-off command has been sent. We can't see them very easily because they're inside that mast. But do watch out just before launch, because you'll see the KZM mast retracting fully. And there's actually another mast underneath the umbilical mast, and it's called the VKM, or the lower stage mast. We can't actually see that right now, but it's connected to the equipment bay of the Block A, the second stage, so that's further down the vehicle. And it houses the electrical links providing communications between the ground and the Block A, the lower stage. And that one will retract 18 seconds before launch, so a couple of things to look out for there. A word about the ignition sequence. On Soyuz, there's a system for checking the health of the engines before it leaves the pad. And what actually happens is the engines on the 4 boosters and the core stage are all ignited 19 seconds before liftoff. Thrust is adjusted to an intermediate level to check the engine readings, and the engines are then gradually throttled up to full thrust. And at that point, the vehicle leaves the pad, and we're getting ready to come up for the 1 minute mark.
Top moins 1 minute, temps décompte.
And we are 1 minute to launch. We're launching the Earth observation satellite, Pleiades 1B, for the French space agency CNES. And we're flying on board the 4th Soyuz to launch from its new home here at the Guiana Space Center. 40 seconds to launch. Soyuz is switching to onboard
Largage du
power.
KZM.
And there goes the KZM being pulled away from the tower. And don't forget to count to 19 once you see the first burn of the engines. Our best wishes to all the teams.
À tous de DDO, attention pour le début de la séquence d'allumage lanceur. Top à Gyros moins 20 secondes. Largage du VKM, Début de l'allumage lanceur. Attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Top. Décollage. Zapusк. Les paramètres bord sont normaux. La propulsion est normale.
And we're off, hauling ourselves against the gravity of the Earth, all 300 tons, lighting up the night sky. Fantastic images there. Usually people watch from the beach, have family picnics and that sort of thing during the day, but I wonder how many people are there tonight at sort of 11 o'clock at night here. He's saying that everything is normal, the propulsion is normal. We're heading north out over the Atlantic Ocean. We'll be travelling up the east coast of America towards the Arctic and then back down towards Australia, where we plan to deliver our satellite, and it'll take us about 55 minutes to get there. We're burning 5 engines at the moment. We've got one on the core stage and 4 boosters. But it's actually the boosters that are doing all the work here, or most of the work. Their job's to get us away from the gravity of the Earth, and we need an awful lot of firepower to do that. They're providing 80% of our thrust right now. For the techies amongst you, that's 790 kilonewtons each. Beautiful images there of the vehicle as it heads into space, and
Séparation des blocs latéraux.
And we're seeing separation here of the boosters. They have burnt their propellant. We don't need them anymore, so they have actually fallen back down to Earth now, and that you can see on the left-hand side is the trajectory. It's showing us how the flight is progressing. Curve is the computer simulation of the scheduled altitude. The white dot on the curve is the actual position of the launch vehicle. A is altitude, and V is the velocity or speed. So we're burning the main core stage now, burns for just under 5 minutes.
La propulsion est normale.
And you can notice that in the middle of the launcher, a sort of a lattice work structure there. More on that later. We're zooming in now to the fairing. The fairing is that section at the front of the launch vehicle, and it's housing our precious satellite.
Le déroulement du vol est normal.
Everything's going normally. The fairing has several jobs. Most notably, it's protecting the satellite from the rigours of the launch. It's very loud at launch. The acoustic vibrations needs to be protected from those, and also friction. The launch is flying through the dense part of the atmosphere at very high speed, so of course the outside of the fairing gets very, very hot. Soyuz launchers operated by Arianespace use the ST-type fairing in the standard configuration. And we're jettisoning the fairing now. We don't need it anymore. We're on the outer edge of the atmosphere, and we have confirmation there, separation of the fairing. The atmosphere is about 100 kilometers deep, and any remaining gas up there is now so thin that the satellite is safe from the effects of friction. And I have to say, it's incredible to think it's taken us only 3.5 minutes to get into space. If you were driving by car, it would take you 100. If you're driving by car at 100 kilometers an hour, it would take you 1 hour. Incredible. Makes you realise how little separates us from, well, the universe. So the bottom left-hand side of the screen, you can see frigate. The upper stage is that gold structure, the round structure, and we can see our satellite for the first time now. It's at the very front. These computer-generated images, there it is at the front, the oblong structure. We're looking at these computer-generated images which are showing us what the experts have calculated is happening to the launcher and the satellite. Basically, the teams plan a very precise schedule of events based on extremely accurate predictions. And these images are a simulation of those predictions. So every movement and every position you see is based exactly on what's been planned for the flight. And then we have ignition of the third stage and separation of the second stage. And the third stage is going to burn for about just over 4 minutes.
Extinction du bloc A, séparation, deuxième, troisième étage et allumage du bloc I.
There we go, we have our confirmation. On Soyuz, the engine ignition of the third stage is a little bit different from Ariane. With Ariane, we separate one stage before switching on the next, whereas with Soyuz, it's the other way round. We switch on the third stage engine before we switch off the second stage engine, and that's why we have that lattice work structure, which I pointed out earlier. It helps to evacuate. Last week, ministers from the 20 member states of ESA met. At the meeting in Naples on the 20th and 21st of November, ministers agreed to continue their support for ESA's space activities to boost Europe's competitiveness and growth.
The economic dimension of space has taken an upper hand over the merely technical, and by investing in space, member states are investing in the economy. And this is why overall commitments have reached over 10 billion euros, and investments will be in new areas with projects such as the adapted Ariane 5 midlife evolution and the Ariane 6, which will follow. We will also participate in NASA's future crew transport system to the Moon. We will develop 2 new telecommunications platforms to improve European competitiveness in the field of telecommunications. We will start working on the second-generation Galileo project, second-generation polar orbit meteorological satellites. So, as you can see for ESA, 2020 is here and now.
The French Minister for Higher Education and Research, Geneviève Fieroso, said the meeting meant European space had taken a decisive step forward. The principle of a new Ariane 6 launcher was agreed, which will be better adapted to upcoming markets whilst continuing to support the employment and skills of industry. Right now we're flying over... Everything going well. Flying over the North Atlantic past the east coast of Canada, heading towards Newfoundland. The flight path takes us up over the Arctic. Then we start heading back down across eastern Siberia, over the east coast of China, down to Southeast Asia and to Australia, where we separate our satellite. We're tracking the launcher using telemetry. Soyuz sends data to ground stations as it flies over, and this tells us how the flight is progressing in real time. And the tracking stations that we're using today are Galileo in Kourou, then Bermuda, which is an island in the Atlantic. Then we lose the signal for about 20 minutes and pick it up again at Jeju, which is the tracking station in South Korea. And then we end up with Perth in Australia. A word about the confirmations. We're seeing milestones happening at the right time, but we get the actual confirmations just a little bit later. That's perfectly normal. It takes a little time to validate the information, so the range operations manager will only call out the confirmations when he actually gets them. Looking here at what remains of the launch vehicle, the third stage there, with the burning its engine out now. It's shut its engine down. You can see it's there, and you can see it there rather, and we can see frigate now with the satellite attached. So we're now beginning...
Acquisition de la télémesure par la station de Bermude.
And we've just acquired the signal at the tracking station in Bermuda. So we're beginning the next phase of the journey. Frigate was that gold structure we could see there. There it is on the left-hand side of the screen. It has 6 spherical tanks organised in a circle. Can you see them? Those round white blobs. 4 of those tanks are for propellant and 2 are for avionics. And then the satellite is attached there on the front, on the right-hand side, and you can see it's attached there via an adapter system. Right now, Frigate is getting ready to switch on its engine, and it takes 55 seconds to do that. It's called the pre-burn phase, and Frigate is accelerating. The aim is to make sure that the propellants are well settled at the bottom of the tanks, a little bit like when you press the ignition in the car.
Donc, fin de propulsion bloquée, séparation frégate, et le frégate est en préparation avant son boost.
And you get pinned to the back seat. So Frigate has now switched on its engine for its first burn. It's going to last about 3 minutes and 39 seconds. Frigate's a very important piece of kit. Its job is to deliver the satellite to its separation orbit, and that's going to take just under 45 minutes. And during that time, it'll switch off its engine
Allumage du moteur de frégate.
and go through a coasting phase. There we have confirmation that the engine's now been switched on. As I said, it's a fascinating piece of technology. It's actually an orbital vehicle in its own right. It's totally autonomous, has its own onboard computer, guidance, navigation, etc. Now, lots of different missions here at the Ariane base.
And a very success for Ariane 5 ECA as she performed her 6th launch this year and her 52nd launch in a row, when she successfully orbited 2 telecommunication satellites, much to the delight of the customers, Eutelsat and Orbital Sciences.
In other campaigns here at the base, preparations for the light lifter Vega's second launch are underway, with the arrival of the various stages here at the Guiana Space Center for assembly.
The heavy lifter Ariane 5 has moved to the final assembly building to be ready for Arianespace's final launch of the year to orbit Skynet 5D and MEXSAT Bicentenario.
At the same time, the various parts of Europe's medium lifter, Soyuz, have arrived ready for the 5th and 6th launches of Soyuz at the CSG in 2013.
EchoStar Corporation has chosen Arianespace to launch its upcoming satellites after a successful launch of EchoStar 17, which reaffirmed confidence in Arianespace's dependability.
Jean-Yves Le Gall represented Arianespace during a working lunch with the Russian and French Prime Ministers at the Franco-Russian Intergovernmental Seminar.
The Foundation for Higher Education and Research was held at the Collège of France in the presence of the French First Minister Jean-Marc Ayrault and the Minister of Higher Education and Research, Geneviève Fioraso.
So, with all 3 launch vehicles, Arianespace is now the only launch services provider in the world capable of launching all types of payloads to all orbits. So it's pretty impressive stuff. Right, we are flying at an altitude of 241 kilometres above the Earth and a speed of 7.79 kilometres per second. Let me repeat that. Per second. Incredible velocity there. Frigate is getting ready to switch off its engine, and it'll then go through into a coasting phase to save propellant. And it's interesting, actually, because Frigate was originally designed as an interplanetary space probe. The Russians developed a number of interplanetary craft over the years, and the Frigate stage follows in their design traditions. It first flew on board Soyuz in 2000. I actually remember it delivering the cluster satellites back in 2000, those satellites to investigate Earth's magnetic field. So Frigate has now shut down its engine, and the onboard computer has sent the command to switch it off. So we are now entering what we call the ballistic phase. Ballistic means without propulsion. So we're travelling high enough and fast enough to cruise without the engine. We're already on orbit, and the coast phase lasts approximately 28 minutes. Soyuz has been launching from the Russian cosmodrome since 1965, and now it's also launching from here, the European spaceport on the equator.
From the 21st of October 2011 to the 12th of October 2012, Soyuz had 3 successful launches from the French Guiana Space Center. Maintaining such a pace on a new launch system is quite unique. It's first and foremost a technical feat, as the system that we are operating today is practically in the same state as it was when it was first launched. One of the major challenges of this project was to get the Russian and European teams, which are very different working methods and cultures, to work together in an operational environment. In this respect, the mission has achieved its goal. One of the reasons for this is the commitment by both sides to bring this project to a successful conclusion. Another is Arianespace's previous experience working for close to 10 years in Baikonur with its subsidiary Starsim. And finally, because Arianespace was involved from the very outset in the development phase, thus ensuring that the system was immediately operational and in phase with customer requirements. As of next year, we plan to have between 3 and 4 Soyuz launches per year from French Guiana, and we already have 12 missions on our order books, which mean 3 to 4 years of continuous activity for the Soyuz program. So as you can see, Soyuz launches from French Guiana are now an essential part of our launch service, adding to and completing the Ariane and Vega programs. The Soyuz launcher addresses a specific market slot, combining the capabilities of a medium launcher with those of the world's top launch facility. Our teams that have developed their expertise with the Ariane program are one of the main ingredients behind our current success.
So we've now lost visibility of the launcher. That means that it's gone out of the range of the Bermuda tracking station, and it's going to be about 20 minutes before we pick up the signal again over Southeast Asia at the Jeju tracking station in South Korea. We have about 26 minutes before Frigate switches its engine back on, and we've got lots of films for you while we wait. Starting with the French space agency, the CNES. They've been developing Pleiades for the best part of a decade as a dual system for both civilian and military users.
The Pleiades 1A satellite was launched on the 17th of December 2011, and its in-orbit commissioning took place on June the 30th, and since then has provided more than 40,000 top-quality images. The satellite is performing very well, with exceptional agility, which has proven a major asset to us. The users, including the Ministry of Defense, Astrium Geoinformation Services and their customers, are extremely satisfied with the quality of the images. This evening, we are launching the second satellite, Pleiades 1B, which will further reinforce the system's capability. We had set this date a year ago, and we are on schedule. Therefore, I would like to congratulate and thank all the contributing parties to this 2-satellite program. Firstly, CNES Toulouse, which has designed this new generation of high-resolution infrared optical satellites, and which is also the commissioning authority of the satellite, of the ground segment and mission control. And CNES Toulouse is also in charge of operations and flight control for both satellites. I would also like to congratulate and thank Astrium, the industrial prime contractor, and also the main supplier of the instrument, Thales Alenia Space. And I would also like to thank and congratulate the CNES Launcher Division and the Guiana Space Center, Arianespace and ESA, who have made the launch of these satellites possible through the Soyuz program in French Guiana. And finally, I would like to thank our European partners, Austria, Belgium, Spain, Italy and Sweden. Once again, I'd like to say thanks to all of you for a job well done.
And observation from space is hugely important. Earth is our home. I think it's fairly safe to say that we have no alternative right now. So the better we understand how our planet works, the better equipped we are to build a long-term picture and project it. And Pleiades will play a vital role in that. The 2 satellites will work as a team, sweeping the planet from opposite sides of the Earth, 180 degrees apart. And this means that together they can take a picture of any place on Earth every day, assuming there's no cloud. Right now, Pleiades 1A is waiting for its twin, 1B.
With Pleiades 1A, we can acquire on average 500 images a day. With its twin in orbit, this will be double to 1,000 images in one day, or the equivalent of 400,000 square kilometers, or roughly 80% of France's surface area. Pleiades' strength, apart from its volumetric analysis capability, lies in its agility, allowing us to move the instrument's line of sight and to acquire multiple targets in a theater of operations, and allowing for different image capture modes such as stereo and tri-stereo, even 100-kilometer wide mosaics in a single pass. It was designed from the outset to promote innovation and put emerging technologies into orbit, such as the gyroscopic actuator developed by Astrium, which has replaced the flywheel, giving Pleiades its great agility. This is a first in Europe. There are also fiber optic gyrometers, which are indispensable for high-quality image geometry. Amongst the instruments developed by Thales Arianespace, one can mention the time delay integrators made of thin silicon. We have also developed interferometry filters, which are required for multispectral channels. We are also working on a technological demonstrator called CXCI for future systems, with an image resolution of 20 to 30 centimeters and a swath of 15 to 20 kilometers.
So, lots of clever technology on board, and it's this sophistication that means that the Pleiades constellation is going to be one of the most powerful Earth observation systems in the world, and it'll enable Europe to rival the American systems. Pleiades is working alongside the SPOT programme. You might have heard of that. And as Jean-Yves Le Gall mentioned earlier in the programme, Ariane launched the first SPOT back in 1986. And back then, SPOT had a resolution of 10 or 20 metres. Now, with its sharp eyes, Pleiades can see details on the ground as small as around half a metre. That's pretty impressive.
Since 1986, cartographers, hydrologists, geologists, agronomists, land planning officers and civil protection teams are just some of the many users who rely on remote sensing and geographic information in numerous fields. Satellite imagery is an unrivaled source of information for monitoring human activities and managing our planet's resources. With the SPOT and Helios satellites, CNES and its partners have developed a range of services for a broad community of civil and military users. CNES is also meeting emerging requirements for very high-resolution imagery through the Pleiades program, the first satellite of which, Pleiades 1A, was successfully launched in December 2011. Pleiades is a dual-use system designed to serve military requirements quickly and securely, while ensuring broad dissemination and sharing of imagery among civil users. SPOT and Pleiades are complementary systems. SPOT 5 and now SPOT 6 and soon SPOT 7, developed and funded by Astrium, offer civil users wide-area 60-kilometer imagery at a resolution of 2 meters. At 70 centimeters, Pleiades offers even higher resolution to resolve much finer detail, but with a narrower 20-kilometer swathe. The satellite partly compensates for this narrow imaging swathe with its extraordinary agility, making it much easier to image areas of interest with new modes like strip mosaic acquisition and instant along-track stereo viewing. The satellite's extremely precise attitude control and guidance system enables it to eliminate image distortion due to angular motion. Location accuracy is also very good. For example, it can image the city of Toulouse from its 695-kilometer orbit at a resolution of 70 centimeters with an accuracy of 10 meters. Many new technologies were developed and qualified by industry partners and in CNES's research labs. One such example is the fiber optic gyros and control moment gyros used in place of momentum wheels. Teams at the Toulouse Space Center and industry partners, Astrium for the satellite, Arianespace for the instrument, CS, CAP and Thales services for the ground segment, were key in developing the Pleiades system. Astrium Geoinformation Services and many science laboratories are also adding value and helping to exploit its very high-resolution imagery. Besides the chief applications for which Pleiades was designed, like mapping, hazard management and defense, CNES has demonstrated the value of high-resolution optical imagery in many other domains. The results from Pleiades 1A have confirmed its promise in such areas as maritime and coastal monitoring, geology, geophysics, protecting biodiversity, hydrology including monitoring of flash floods, forestry and agriculture. In December 2012, Pleiades 1B will join its twin Pleiades 1A in orbit to further improve revisit times and acquisition capacity. With these two satellites, the Pleiades program offers a particularly responsive constellation and a preferred source of data for the defense community and institutional and private users. Alongside CNES, the French Defense Procurement Agency, partner agencies, European manufacturers and research laboratories have pooled their talents and resources to put into space the innovative technologies driving the Pleiades mission success. Keeping watch over our planet from space to ensure its sustainable development calls for ever higher resolutions that can only be attained by advancing technologies in the years ahead. That is why, as it did for Pleiades, CNES has already initiated a demonstrator program called CXCI to take Earth observation to the next level.
Fantastic image there of Mont Saint-Michel off the coast of France. So Pleiades in French, Pleiades or Pleiades in English, sometimes known as the Seven Sisters, a constellation. And it does have a lot of canny tricks on board, a very, very clever piece of kit. Here we are at an altitude of 473 kilometres above the Earth, and we're travelling at 7.64 kilometres a second. The General Thierry Caspar there come to join us. The ministry will be a preferred customer.
The French Defense Procurement Agency oversees all French military space programs. In 2005, it launched the SSO Ground Segment Program to enable the defense community to task, receive, produce, disseminate and exploit imagery acquired by the optical and radar systems to which it has access from mainland France and theatres of operation. It is thus able to obtain imagery quickly from the two Helios 2 military satellites, as well as the German SAR Lupe and Italian Cosmos SkyMed radar satellites, plus the two Pleiades satellites, Pleiades 1A since February 2012 and soon Pleiades 1B. Pleiades offers defense users additional imaging capability to complement existing military systems. Once these two satellites are operational, defense users will be able to order 50 images a day. This capability will meet the military's growing satellite imagery requirements. Pleiades helps to acquire more frequent imagery of areas of interest, fulfilling the need confirmed by recent crises for faster access to information. These satellites also provide color imagery to more clearly identify wetlands or dense vegetation, for example. The Pleiades satellites' great agility enable them to collect multiple images of areas of interest.
Ce qui compte pour les opérations militaires, c'est la
Fresh and frequent information is what matters most for military operations. That means getting the right image at the right time. The two Helios military satellites and the two Pleiades dual-use satellites give us the capability to better meet users' needs and keep pace with the tempo of operations. Pleiades is the latest in a long line of space programs in the last 20 years that have given France a world-class global military surveillance capability. The precise, reliable and timely information this capability provides supports France's independent analysis, decision-making and action.
So, Pleiades continues Arianespace's partnership with the French Ministry of Defence. And the fact that we'll have two satellites means that they can tackle all kinds of situations, such as rescue or crisis management after an earthquake, for example. Other Pleiades trickery, we heard earlier about those special devices called control moment gyros. Well, these are going to allow the satellites to slew very fast from one point to another. Just imagine there's, say, 200 kilometres between point A and B. Well, normally you'd need 20 seconds to switch, but Pleiades can do it in 11 seconds. That means you get double the number of images. And the satellites cover different parts of the globe throughout the day. Let's find out more about that.
Le système est programmé 3 fois par jour. Le matin sur la zone comprenant le Moyen-Orient, l'Europe et l'Afrique, l'après-midi sur la zone Amérique et le soir sur la zone Asie et Australie. Ce faisant, il est possible de prendre en charge des demandes d'acquisition le plus tard possible en fonction de la zone et de mieux s'adapter aux prévisions de couverture nuageuse. Cette facilité augmente la capacité de réactivité de Pléiades. Grâce au débattement latéral du satellite, il est possible d'effectuer des prises de vue de n'importe quelle zone de la Terre en 24 heures avec 2 satellites, en 48 heures avec un seul. Les demandes d'acquisition d'images sont quotidiennes et dépassent la capacité d'acquisition des satellites. La programmation consiste donc à obtenir la meilleure séquence d'acquisition d'images en tenant compte des priorités exprimées par les utilisateurs du système, des prévisions de couverture nuageuse et de la capacité des satellites. Le système est ouvert à 3 opérateurs, 2 opérateurs militaires, la France et l'Espagne, et un opérateur civil. La programmation permet de partager le système entre les utilisateurs militaires qui disposent de la priorité de programmation sur un nombre limité d'images et des utilisateurs civils qui peuvent travailler sur les 95% de la ressource satellite restante. Les demandes d'acquisition des utilisateurs sont collectées et traitées au centre de programmation du CNES. Chaque jour, la séquence d'acquisition d'images est élaborée et optimisée. Sur cet exemple, voici les besoins initiaux de l'opérateur militaire français et finalement son choix. Idem pour l'opérateur militaire espagnol. Puis, la conjugaison des besoins militaires. Enfin, les besoins de l'opérateur civil et le choix effectué par le centre de mission. L'agilité du satellite et ses capacités de visée avant et arrière permettent, sur cette zone très demandée, de répondre de manière efficace aux besoins des utilisateurs.
And we're flying down from the Arctic, down over eastern Russia, heading south towards the east coast of China. And you can see over on the left-hand side, we're still climbing in altitude. We're at 570 kilometers now. And we're travelling at a constant, pretty constant speed. So despite our coasting phase, we're still going higher and higher. With Pleiades, we're really entering a new era in terms of imagery from satellites. This is due to a combination of factors. We've got 2 satellites, so we've got double the ability to collect pictures. There's the agility factor, which enables better resolution. And fast reaction times. So the system's able to respond to specific requests very urgently.
Il y a 10 mois à peine,
10 months ago, Pleiades 1A, the first satellite in the Pleiades series, was orbited by a Soyuz launcher from Kourou. Orbit positioning was nominal and in-orbit checkout went without a hitch. The system entered operational service less than 3 months later. Image quality is excellent, radiometry and geometric accuracy are really good, and of course, Pleiades' agility is proving hugely popular, particularly with defense, institutional and commercial users. The results obtained with Pleiades offer great potential for a host of applications. For the OFEO project, Pleiades 1A is being tasked to assess requirements and challenges for more than 80 scientific and institutional users. The field of applications is vast, including, for example, humanitarian aid, crisis management, and natural disaster response.
In July 2012, we tasked Pleiades to image flooding in Krimsk, and we were able to map flooded areas, collapsed bridges, and refugee camps within less than 7 hours of image acquisition.
While speed of response is vital to natural hazard management, the quality of Pleiades imagery also makes it possible to observe fragile ecosystems and monitor their evolution.
Another example is the impact of human activities in the far south of New Caledonia. Using Pleiades imagery, we were able to quantify soil erosion due to nickel mining, as well as monitor endemic vegetation and map coral reef health.
1 year after the satellite's launch, Pleiades imagery is already serving commercial applications for many users and delivering new generation geo-information.
Pleiades is ideal for all kinds of mapping applications, especially at relatively large scales, since we can go as far as 1 to 100,000 with ease. Our partnership with a Chinese firm is an excellent example. Pleiades is supporting the One Map, 1 Year project to map China's national territory every year.
The satellite's great agility allows it to acquire very high-resolution stereo imagery.
Pleiades also enables us to meet 3D data requirements. A customer recently asked us for a 3D model in Kazakhstan to help route a pipeline. At the end of the day, this solution will save them money and allow them to identify the cheapest route.
The high resolution and location accuracy of Pleiades imagery are vital when observing detailed landscape features, particularly for precision agriculture.
Pleiades is also very useful for wine growers, since its resolution makes it possible to pick out the precise number of vine stocks in each row, notably when they're very close together. It's also useful for gauging the health of a field and knowing exactly where to treat vines or add inputs as part of a more integrated growing strategy.
The Pleiades system's new capabilities complement the SPOT satellites, bringing users a range of imagery solutions to better serve their evolving and diverse needs.
A customer's boat was boarded and captured by pirates. We were able to track the boat down using the last positional readings from its locator beacon. We tasked Spot to acquire this image, where we spotted a small bar that looked like it could be the boat. We then tasked Pleiades to zoom in on the area with its higher resolution to confirm that it was indeed the boat taken by the pirates and give the customer its exact position.
Pleiades 1B will double the system's acquisition capacity and provide daily revisits to any point on the globe. With 2 satellites, Pleiades will offer an operational acquisition capacity of 900 images a day to better serve regular monitoring needs and obtain cloud-free imagery more quickly, a level of performance that makes Pleiades a unique and vital tool for all users of satellite imagery.
And if you want to commission Pleiades to take a picture specifically for you, or you want to search through pictures in the database, you can subscribe to Astrium's Pleiades portal.
Les tâches sont normaux. Début des manœuvres d'orientation en vue de la préparation du deuxième allumage de l'étage frégate.
Which is a nice user-friendly portal. We're just getting confirmation there that we're going into, we're orientating and getting ready. We're receiving telemetry once again. Soyuz has picked up the signal at Jeju, and it's stored the flight data from the last 20 minutes in its memory, and that's now being downloaded to the Jeju station. Pleiades' speedy reaction times make it an ideal tool for rescue teams.
En décembre 2011, le satellite Pléiades 1A rejoignait la brigade de satellites qui œuvre dans le cadre de la Charte internationale Espace et catastrophes majeures. Cette brigade se mobilise lorsqu'un pays est frappé par un cyclone ou une inondation par exemple, et qu'il est urgent d'évaluer l'ampleur des dégâts. Aujourd'hui, c'est le satellite Pléiades 1B qui vient renforcer cette escadrille et prêter main forte aux sinistrés.
Le système Pléiades est extrêmement réactif. On peut reprogrammer le satellite très rapidement, ce qui permet de répondre à des situations d'urgence, donc de catastrophes majeures. Les images Pléiades sont très précises, elles fournissent des données à moins de 1 mètre de résolution. Par exemple, sur les inondations de l'été 2012 en Russie, sur la ville de Krimsk, qui ont eu lieu dans des zones urbaines, les images Pléiades ont été très utiles pour évaluer l'extension des dégâts, justement en zone urbaine. Il s'agit d'avoir là une résolution meilleure que le mètre pour voir quels sont les bâtiments qui sont touchés ou pas.
Plus récemment, lorsque l'ouragan Sandy a frappé Haïti, les images acquises par Pléiades 1A avant et après les inondations ont permis une cartographie détaillée des déplacements de barges de la rivière Grise de Port-au-Prince et l'inventaire exhaustif des bâtiments submergés. Avec le satellite Pléiades 1B, c'est la réactivité de la constellation qui sera améliorée.
Le premier Pléiades a déjà été utilisé dans plusieurs activations charte, mais l'arrivée du deuxième satellite Pléiades, fin novembre 2012, va être vraiment un plus énorme pour la charte, puisque grâce aux 2 satellites, on sera capable d'observer chaque point du globe tous les jours, donc à une résolution très importante.
Well, we're now coming up to the next phase in our journey, and I'm delighted to welcome our guest, Antoine Courtois, who I have stolen from the French commentary box next door. Hi, Antoine. Thanks
Hello.
for joining us. Antoine's a propulsion and telemetry expert at Arianespace. Antoine, frigate's getting ready to switch its engine back on, isn't it?
Absolutely. We are coming to the end of a pre-burn phase, and this phase lasts 55 seconds. During this time, frigate accelerates. It's using small thrusters from the attitude control system, and this pushes the fluids back, so it ensures the propellants are settled to the bottom of the tanks, and this means the feeding lines are full of propellant, which is essential for the engine to ignite properly.
And frigate's firing its engine in a minute. There we go. And this is going to burn now for 4 minutes. So we're making our way to the injection point. That's where we literally inject the satellites into space so they can continue on their journey. Why have we switched the engine back on now, Antoine?
Well, we need to start building up speed again. Right now, we are traveling at 7.4 kilometers per second, and we need to get to 7.6 kilometers per second in order to inject the satellites onto its circular
Confirmation
orbit.
de l'allumage frégate.
It will take us about 11 minutes to get to the injection point, but it won't be 11 minutes of propulsion, because we will obtain the required velocity in only about, let's say, 3 minutes. Then we will be able to switch off the engine.
So why do we have to wait another 8 minutes or so before we can separate the satellite?
Well, we'll have to initiate the orientation maneuvers thanks to the onboard attitude control system. And don't forget that Pleiades 1B needs to be positioned exactly opposite to Pleiades 1A on the other side of the Earth. It needs to be on the same orbit, but 180 degrees from its twin. So we will have to wait in order to reach the accurate injection position, and this is planned for a few minutes more.
Just over 11 minutes' time. Everybody very cool, calm and collected. It's the double act between the 2 satellites which gives the constellation its efficiency, and like its twin, Pleiades B will go through various tests before becoming operational. Let's find out about those.
In-orbit checkout of the Pléiades 1A satellite was completed in 2 phases. The first phase, lasting 2 months, was devoted to functional checkout. Results were already encouraging and in line with our expectations after 2 weeks, and this was confirmed 2 months later. The second phase, lasting 6 months, focused on image quality. At the end of this period, all of our image quality specifications had been met, and in-orbit checkout was signed off successfully.
Cet envol a été prononcé 6 mois après le tir avec un franc succès.
As regards satellite agility, we were able to confirm as early as the third day the sensor's ability to steer at a speed of 3.5 degrees per second to view off-track at angles up to 50 degrees. 1 year after launch, the satellite is successfully meeting demand from users, delivering 450 images a day to civil customers and 50 a day to military users. Pléiades 1A is now fully operational.
As I said earlier, Antoine, you're an expert in telemetry. Where are we now?
Right now we are flying over Taiwan and we are heading down over Southeast Asia towards Australia, where we will pick up the signal at Perth. Now we are tracking the launcher with the Jeju ground station, and by the way, the men and women at Jeju had to reconfigure the tracking facility very quickly, and that's because they had to prepare to monitor the Korea space launch vehicle, which was supposed to be launched 2 days ago, but it has been postponed. So they've been quite very busy.
They certainly have, and they've done a good job. And you analyse the data afterwards, don't you?
Yeah, after the flight, the data we collect from all the tracking stations is sent to the telemetry treatment center in Toulouse, and they process it so that the teams can then perform the post-flight analysis.
Everything's going normally, he says. So, frigate's getting ready now to switch off its engine. What's happening, Antoine?
And this is the very last phase of the burn. We're now reducing the thrust, and this is to prevent any depletion of the propellant. Generally, it's better for any engine to run down any remaining fuel at reduced power, and that's because it's steadier.
And here we got the scheduled frigate main engine second cut-off. And we can see there we will need to position the satellite very precisely so that we can inject it correctly for the next phase of its journey.
Yes, that's true. We need to put the satellite in the correct attitude so it can separate. And to do that, frigate must perform a very carefully planned set of maneuvers. We call this the orientation phase. And to do this, frigate is equipped with 12 small thrusters. They use hydrazine to give bursts of gas, and this way we can move frigate in any direction we choose. A frigate, in fact, is a clever piece of technology.
It certainly is, and it's carrying ultra-sophisticated imaging equipment built by Thales Alenia Space.
Bonjour à tous.
Good evening. I am delighted to be here tonight with you for this launch, a very special moment for the Pleiades program, coming less than a year after the success of Pleiades 1A. Thales Alenia Space is well known for its high-performance optical instruments used for military and dual purposes. Our expertise and unique position in the industry are the result of over 30 years of experience with the Helios 1 and 2 programs. This has made it possible to develop the know-how and resources required for the integration and adjustment of the instruments on board Pleiades 1A and 1B, and which also be used for the CSO program. Over the past year, Pleiades 1A has been delivering very high-quality images with performances surpassing expectations. These outstanding images have helped to place French industry amongst the world's major players. Both the ability of French companies to provide relevant solutions to prospective customers and the numerous successes obtained thus far are proof of this. I would like to extend my warmest thanks to CNES, the DGA within the Ministry of Defense, for their trust, the Astrium teams and our industrial partners for our excellent cooperation, which will continue with the CSO program. This shows once again the excellence of French industry in this area.
And I have returned,
Fin de
Antoine,
poursuite
to...
normale de la télémesure par la station de Jeju. Réacquisition de la télémesure par la station de Perth dans environ 4 minutes.
So Antoine has returned now to the French commentary box. So Thales Alenia Space provided the instruments and Astrium built the satellite at their plant in Toulouse. I must say that European industry has a lot to be proud of when it comes to Earth observation, as to all the folk working in the ground segment and flying the satellites. Europe already plays a leading role worldwide, and Pleiades will mean an even higher performance capability to rival that of the US observation systems. Thales Alenia Space and Astrium have equipped the satellites with clever technology to enable it to win a sizable market share.
I would like to seize this opportunity to pay tribute to CNES and the DGA within the Ministry of Defense, who for over 40 years have helped to shape the French space observation industry. Completing the Pleiades constellation is, in simple terms, the 7th stage. With each new stage, the French Earth observation industry has improved its performances by reducing costs and demonstrating its capacity to innovate in all areas, and not only with technical breakthroughs. In France, we are successful when we are ambitious, and I sincerely hope that this launch will further boost this ambition. The Pleiades program offers exceptional opportunities, but like its predecessors, it is only one step on the way to new systems and new services that will have to adapt to future user requirements. We have the ideas, we need the ambition to implement them. I would also like to thank all of Astrium's partners in this endeavor. Of course, Astrium was in charge of the satellite and ground system segments, and it will be the one to operate the constellation. However, it is thanks to their support that we were able to do so and will continue to be. Whether it is industrial giants such as Thales, who provided the highly sophisticated instruments, or the many SMEs who supplied the core of the satellite and ground segments, each and every one gave of their best. And finally, I would like to thank Arianespace for its professionalism, exacting standards, and the special care given to Pleiades 1B. This is the second satellite in the series, yet it was built with the same utmost dedication as its twins and its predecessors. And so, with a certain amount of emotion, that all of those who participated in its production would like to wish it a safe flight.
Bon vol.
And there it is, our satellite built with so much passion and love. So we've plateaued out. If you take a look at the curve, you can see that we're now not really gaining much in altitude, just fractionally though we are, 687.1 kilometers above the Earth, and we're travelling at 7.6 kilometers per second. It always amazes me actually, because when you look at these computer-generated images, it looks as if we're flying incredibly slowly and as if everything's happening very slowly up there in space. Of course, the reality is that we're travelling at phenomenal speeds. Earth observation missions require all sorts of orbits, and thanks to its family of vehicles and the flexibility of Frigate, Arianespace can provide them.
Bonjour Lionel.
Good morning, Lionel. 1 year after the successful launch of Pleiades 1A on a Soyuz launcher from the French Guiana Space Center, here we are again for its twin, Pleiades 1B. You feel very much at home here, don't you?
Yes, it's certainly becoming a habit being in crew for a Pleiades launch. The fact that the launches are so close together means that we have fine-tuned the mechanics of the campaign, which ran smoothly and was right on schedule.
So is it important for you as a customer to work with a launch provider like Arianespace, which coordinates all the different parts and guarantees the overall smooth running of the program and a seamless campaign?
Of course, having only one interface facilitates the technical dialogue for us, and Arianespace's role in coordinating the campaign is a real asset for the customer. The launch costs represent a large share of the budget for an Earth observation program, and this is why having Soyuz and Vega options in French Guiana is a real plus for low-orbit Earth observation missions. And CNES is already looking beyond to Pleiades' successor programs, the CSO, which follows Helios 2, which is intended to be compatible with both Vega and Soyuz. The first CSO satellite is scheduled for launch in 2017, so we will certainly have more opportunities to work together in the future.
So our next tracking station is Perth in Australia, and the guys and girls there will be tracking separation for us. Just a reminder about these computer-generated images that we're looking at. They're really stunning, and they're showing us what the experts have calculated is happening to the launcher and the satellites. As I said earlier, the teams have planned a very precise schedule of events, and the images are a simulation of those predictions. So every movement and every position that we see is what's actually scheduled. We get our confirmations a little bit later than the milestones actually happening in real time. It takes a little bit of time for the validations to get to the range operations manager, and he calls them out as soon as he gets them. So we're coming up now to the separation of the satellite. The way it works is there's a clamp band. All the parameters are normal. A clamp band attaches the satellite to its adapter, and when the separation time comes, a pyrotechnic system is triggered, and that loosens the clamp band. And then there are 8 springs which effectively ping the satellite away from frigate. So take a look at the left-hand side of the screen. There we have our curve, the trajectory. You can see that we were climbing. We were climbing pretty steadily, and now we have plateaued out. And our altitude coming up to nearly 700 kilometers above the Earth. That's where our satellite will be taking its images from. Those beautiful, stunning, clear images. I think we can expect to be seeing those.
Confirmation de la séparation du satellite Pléiades 1B.
And we have confirmation that Pleiades 1B has been separated. And there it goes, heading out into space. Congratulations to all the teams. Very happy faces there in mission control, the Jupiter control room here at the Guiana Space Center. Congratulations to the French Space Agency, the CNES, to the French military, to Astrium and Thales Alenia Space, who have provided their fabulous skill, and to everybody in the ground segments and all you folk who are now taking over the satellite. And congratulations to all the Soyuz teams at Arianespace, the Russian and the European teams. So, well, Frigate's job is not quite finished. Right now, the satellite is heading out to do its job, but Frigate will have to take itself on another circuit of the Earth. We've already done half a lap of the Earth, and Frigate will do another lap because it's going to go through its passivation phase and then into what we call a graveyard orbit, which will take it back down into the Earth's atmosphere where it'll burn up. These were the scenes earlier tonight with that beautiful launch of a Soyuz, the 4th Soyuz from the Guiana Space Center. Its new home here on the equator, on the edge of the Amazon rainforest. They've all been working very, very hard.
Bien. Eh bien, Messieurs les ministres, Mesdames et Messieurs les parlementaires, Mesdames et Messieurs les officiers généraux, Mesdames et Messieurs, comme vous venez de le voir, ce nouveau lancement parfait de Soyuz OCSG vient de placer sur son orbite le satellite Pléiades 1B. Et je pense que nous pouvons tous nous en réjouir. D'abord, ce nouveau succès est le 4e succès de Soyuz OCSG et à l'évidence, il démontre la maturité de l'ensemble de lancements Soyuz qui a été construit ici même en Guyane par l'Europe et la Russie. Ensuite, C'est le 9e lancement de l'année au CSG, 9e, ça n'était plus arrivé depuis plus de 10 ans. Après un lancement de Vega, 6 lancements d'Ariane 5 et un autre lancement de Soyuz, ce qui confirme le succès de la famille et des lanceurs européens. Et bien que nous soyons, je ne sais plus si c'est le 1er ou le 2 décembre, mais disons début décembre, j'en parlerai tout à l'heure, l'année n'est pas tout à fait finie. Enfin, la mise en orbite de Pléiades 1B intervient juste un peu moins d'un an après celle de Pléiades 1A, déjà par Soyuz au CSG, et va, comme cela a été dit dans la vidéotransmission, considérablement renforcer nos capacités d'observation. Je voudrais donc remercier et féliciter très chaleureusement notre client d'Arianespace, le CNES, et en particulier son président, mon ami Yannick Descata. Voilà. Le remercier d'abord pour avoir confié à Arianespace le lancement des 2 satellites Pléiades par Soyuz au CSG, alors que ce projet n'était qu'un très lointain projet. Le remercier aussi pour tout le travail fait ici par le CSG pour la réalisation des lancements, et l'enchaînement parfait de cette fin d'année étant particulièrement impressionnant. Et puis le remercier enfin pour avoir construit l'ensemble de lancements Soyuz, le 7e au monde après les 2 qui existent au Kazakhstan et les 4 qui existent à Plesetsk, et dont nos partenaires russes me disaient à la seconde que c'est le plus réussi au monde, et d'ailleurs ils vont s'en inspirer pour en construire un autre dans l'est de la Russie. Donc quelques jours après la réunion ministérielle de Naples, au cours de laquelle les 20 ministres européens chargés de l'espace ont donné, à l'initiative de la France, un nouvel horizon à notre politique spatiale, en décidant le programme Ariane 6, conçu par le CNES et qui s'envolera du CSG au cours de la prochaine décennie, finalement, dans quelques années. Dans quelques années, on fera un discours ici à ma place pour parler d'Ariane 6. Je crois qu'il faut s'en féliciter. Eh bien, je pense que nous pouvons applaudir les femmes et les hommes du CNES auxquels nous devons, le CNES a un peu plus de 50 ans, donc ce demi-siècle d'engagement, de réalisation et de réussite. Je voudrais aussi remercier tous ceux auxquels nous devons le succès de ce soir. D'abord, tous ceux qui sont, et ils sont très nombreux, qui ont préparé et mis en œuvre ce lancement en Russie, en Europe et en Guyane, avec une mention particulière pour l'équipe de lancement, avec nos partenaires russes et tous leurs associés européens, qui ont travaillé toute la nuit après la tentative d'hier soir. Comme vous le savez, il a fallu vidanger le lanceur, d'abord ramener le portique, vidanger le lanceur, changer l'équipement qui nous avait créé quelques soucis, retester. Je ne vous cache pas que nous avons eu quelques soucis avec un taux d'humidité un peu capricieux, mais finalement, nous y sommes arrivés. Donc chapeau, parce que ce n'était pas évident. Je veux aussi remercier les équipes du CNES et de l'industrie qui ont conçu et qui ont construit Pléiades 1B et qui nous regardent à Toulouse et à Cannes. Je souhaite aussi remercier nos forces armées qui assurent ici, en Guyane, la sécurité de nos lancements, parce qu'elles font un travail formidable, sans lequel nous ne pourrions pas lancer, et ce travail est parfois méconnu, Monsieur le Ministre, et je vous propose qu'on les applaudisse, parce que vraiment, pour les avoir travaillés souvent dans l'ombre, je peux vous dire qu'elles font un travail absolument extraordinaire. Et enfin, je voudrais saluer tous ceux qui sont venus, même si l'assistance ici en Guyane est un peu clairsemée, tous ceux qui sont venus et qui sont restés au CSG pour assister à ce lancement, en particulier mon ami Paul Quiles, alors qu'il était ministre de l'Espace, qui a joué un rôle fondamental dans le développement d'Ariane 5 et d'Hélios. Donc merci, Monsieur le Ministre. Donc voilà ce que je souhaitais vous dire après ce nouveau succès, et sans plus tarder, j'ai l'honneur et le plaisir de céder la parole à M. Jean-Yves Le Drian, ministre de la Défense, qui a modifié son emploi du temps pour être de nouveau parmi nous ce soir, ce dont je le remercie très chaleureusement. Merci.
Bien, Monsieur le Président d'Arianespace, Monsieur le Ministre, cher Paul Quiles, J'ai plaisir à revoir encore aujourd'hui. Madame députée, monsieur le sénateur, mesdames et messieurs, il y a des moments comme ça, très heureux. Je dois dire que pour le nouveau ministre de la Défense que je suis, cette journée sera très forte pour moi. D'abord par l'événement que je viens de vivre avec vous. Je vais vous en reparler, mais aussi pour un événement que vous ignorez encore, je pense. Le dernier soldat combattant d'Afghanistan vient de rentrer à Kaboul, aujourd'hui. Et c'est aussi un mois avant ce que l'on avait prévu et dans des conditions de sécurité totale. Et j'en suis aussi très ému, donc c'est un jour dont je me souviendrai. Je voudrais vous féliciter, les uns et les autres, de ce succès, succession de réussite et d'excellence, même objectif des uns et des autres, vous l'avez rappelé, à la fois Arianespace, mais le CNES, mais les entrepreneurs, les entreprises Astrium, Thales, Arianespace et tous celles que je ne peux pas citer. Féliciter aussi l'équipe Soyuz, à la fois pour sa compétence et sa réactivité, parce qu'après l'incident d'hier, la réparation fut prompte et le succès au rendez-vous. Vous dire aussi que ce deuxième satellite Pléiades, mais vous le savez, nous fait franchir une étape dans le développement de notre système de renseignement militaire. Vous dire aussi que je suis totalement convaincu, à la suite de ce qu'a initié Paul Quiles à son époque, que les systèmes spatiaux contribuent de façon décisive à l'autonomie de décision de la France. Je suis totalement convaincu que l'espace contribue à la liberté de l'action de notre pays, à sa souveraineté et au renforcement de l'efficacité de ses forces armées. Et que les conflits et opérations militaires récentes, j'en citais une à l'instant, ont confirmé l'atout majeur que constituent les outils spatiaux, qui nous permettent de disposer partout et sans délai d'une supériorité tactique essentielle. Et au-delà de cette conviction et de cette nécessité, surtout à un moment où on s'interroge sur les scénarios de l'avenir dans le cadre du livre blanc, je dois dire aussi que la maîtrise de ces outils donne à notre pays une vitrine vivante de notre très haut niveau technologique et de notre excellence dans ses réalisations. Et puis enfin, je constate avec intérêt que, par le biais de la constellation Pléiades, la défense montre qu'elle sait optimiser la dépense publique en favorisant les synergies issues de la recherche duale civile et militaire. Il y a donc beaucoup de raisons de se réjouir ce soir de l'événement qui vient de se passer, mais aussi des stratégies et des perspectives qu'il nous dessine pour l'avenir. Donc je vous félicite encore une fois chaleureusement et vous redis le grand plaisir que j'ai eu à assister à mon premier lancement. Merci.
Bien. Merci, Monsieur le ministre, pour ces paroles extrêmement encourageante. Donc je vais clore la vidéotransmission. Prochain rendez-vous, je vous l'ai dit, l'année n'est pas terminée, le 19 décembre avec cette fois-ci Ariane 5, Skynet 5D et Mexsat Bicentenario. Et comme ce soir c'était le 9e lancement, eh bien si tout va bien, ce sera le 10e. On l'avait dit au début de l'année, je pense qu'il y avait peu de gens qui nous croyaient. Je crois qu'on est en train de s'engager sur la dernière ligne droite, mais tant que ce n'est pas fait, ce n'est pas fait. Donc rendez-vous le 19 décembre. Merci et bonsoir, bonjour, puisque c'est déjà le 2 décembre. Merci.
So, it's mission accomplished once again for Arianespace. Pleiades 1B is heading out to join its twin in space. Congratulations to all our colleagues, to the European and the Russian side, and in particular to the Pleiades 1B teams. Congratulations also to the European satellite industry for this major achievement, and well done to everybody at Arianespace for a truly excellent job. It was a beautiful launch. We were very lucky to see it lighting up the night sky. So the best of luck to all the teams with the next phase of your operations. Thanks for joining me here live at the Guiana Space Center for the 4th launch of a Soyuz from the equator. From me, Katie Haswell, goodbye.